On the 30th of August 2026, a telescope will be launched from Florida on a Falcon Heavy rocket. It carries a 2.4-meter mirror, the same size as Hubble's, and a camera of 300 megapixels that sees a patch of sky about 100 times wider. Its job is to survey something like 1 billion galaxies, and to work out what is pulling the universe apart. It goes up 8 months ahead of schedule, which almost never happens to a $3 billion observatory. It is named after a woman whose school told her not to take mathematics. She was also, for a while, the only woman in the room at almost every table where the future of American astronomy was decided. Her name was Nancy Grace Roman, and this is what she did with the rest of that century. She was born in Nashville, Tennessee in 1925. Her family moved often. Her father was a geophysicist, and when she asked him a scientific question, she got a scientific answer. It is a small thing, and it recurs in the biography of almost every scientist who started young. At 11, she started an astronomy club. She and her classmates met once a week to learn the constellations out of a book. She was the one who organized it. That detail turns out to describe the next 60 years fairly well. By the time she was 13 or 14, she had decided she was going to be an astronomer. She never changed her mind, and almost everyone she met tried to make her. She once asked her high school guidance counselor whether she could take a second year of algebra instead of Latin. In Roman's words, she looked down her nose at me and sneered, "What kind of lady would take mathematics instead of Latin?" Roman told that story for the rest of her life. She took the mathematics. She was not being singled out. This was the ordinary advice given to able girls in 1940s America, delivered kindly by people who thought they were helping. It did not stop there. At Swarthmore, the head of the observatory told her he usually tried to dissuade women from going into astronomy, but that she might be all right. That was the encouragement. So, she went on to the University of Chicago and finished a doctorate in 1949 on a group of stars moving together through the galaxy. Stars that share a motion through the galaxy usually share an origin. Reading those groupings is one way of working out the history of the Milky Way. She stayed on at Yerkes Observatory. She did good work, including finding that stars made of different material move differently through the galaxy, which was a real result. And she could see that there was no future in it because women were not given tenure. She's been blunt about this. She liked the research. She was good at it. She could count the number of women in permanent astronomy posts in the United States on not very many fingers. So in 1955, she left academic astronomy for the Naval Research Laboratory and worked in radio astronomy instead. Radio astronomy was barely a decade old as a discipline. It was one of the few doors that was actually open, which is where she was in 1959 when a man asked her a question at a lecture. NASA was 6 months old. He asked whether she knew anyone who might like to come and set up a program of astronomy from space. She understood what was being offered. She said later that the idea of coming in with a clean slate and of influencing space astronomy for 50 years was more than she could resist. She took a pay cut and joined. She was 33. The agency had existed since the previous October. In 1960, she became NASA's Chief of Astronomy. She was the first woman to hold an executive position at the agency. At the time, NASA employed a great many women. Almost none of them were making decisions about what the agency would build. There was no space astronomy program. There was her, and a budget, and a mandate. What she built over the next 19 years is most of the reason we have telescopes above the atmosphere at all. The job was not doing astronomy. It was deciding for a whole country which astronomy would be possible for the next several decades. The atmosphere is the problem. It blurs everything, and it absorbs most of the spectrum outright. Ultraviolet, X-rays, most of the infrared. From the ground, you were looking through frosted glass at a fraction of the picture. Everything astronomy had ever done, until then, had been done through that filter. Roman ran the programs that got instruments above it, the orbiting solar observatories, the orbiting astronomical observatories. Later, the International Ultraviolet Explorer, and the beginnings of the Cosmic Background Explorer. Some of those failed. The first orbiting astronomical observatory died within days of launch. The program continued because she argued that it should. She also spent those years on something much harder to sell, a large optical telescope in orbit. The idea was not hers. Lyman Spitzer had written it up in 1946, before there were rockets to do it with. Turning it into a funded program took about 30 years. Congress was not the only obstacle, or even the first one. It was astronomers. Many of them saw an enormous space telescope as a threat, one instrument that would swallow the budget for every ground-based observatory they wanted to build. It is not an unreasonable fear. A flagship mission does consume budgets. The argument had to be won inside the field before it could be won outside it. Roman organized the committees that turned a contested idea into a specification. She has said her role was to get astronomers to agree on what they wanted, then to convince Washington that they wanted it. That is not a glamorous description of a job. It is also, more or less exactly, how large scientific instruments come to exist. That telescope became Hubble, which spent its first 3 years as a punchline, because the mirror was ground to the wrong shape and every image came back blurred, until astronauts fitted corrective optics in 1993. It launched in 1990. Roman had retired from NASA 11 years earlier. People began calling her the mother of Hubble. She was uncomfortable with it, because she thought it took credit away from the people who built the thing. That instinct, to hand the credit outward, is worth noticing. It is one of the reasons this kind of contribution is easy to leave out of the record. After NASA, she did not stop. She worked as a contractor, she taught, she spent years going into classrooms, and she was particular about which ones. She kept telling the story about Latin and mathematics to girls who were still being asked versions of the same question. She was still teaching into the late 1990s. Nancy Grace Roman died on the 25th of December, 2018. She was 93. In May 2020, NASA took a telescope that had been called WFIRST and gave it her name, which brings us back to the rocket on the pad. So, the Nancy Grace Roman Space Telescope has a 2.4-meter primary mirror. So does Hubble. The difference is what sits behind it. There is a good story in that mirror. NASA did not grind it. In 2012, the National Reconnaissance Office, the people who run America's spy satellites, donated 2 surplus mirrors it no longer needed. Surplus is doing some work in that sentence. These were finished optics of a quality NASA would have spent years and a great deal of money producing. Optics of that class are not built for astronomy. This one is going to be used for it. Behind it sits a 300-megapixel infrared camera made of 18 detectors tiled together. Hubble's view is famously deep and famously narrow, the width of a grain of sand held at arm's length. Roman sees the same sharpness across a patch of sky about 100 times larger. Put it another way, to cover the area Roman images in one exposure, Hubble would need about 100. That difference is the entire point. Hubble stares. Roman surveys. In 5 years, it is expected to map something on the order of 1 billion galaxies. It has 2 jobs. The first is dark energy. In 1998, 2 teams measuring distant supernovae found that the expansion of the universe is not slowing down. It is speeding up. Nobody knows why. The name for whatever is doing it is dark energy, and the name is all we have. It is roughly 70% of everything in the universe, and it has no explanation. Ordinary matter, stars, planets, gas, us, is about 5%. Roman will measure it 3 separate ways, so that the answers can be checked against each other. 3 methods that fail differently. If they agree, the answer is probably real. If they disagree, the disagreement is itself informative. It will map how 1 billion galaxies are distributed and how their light is bent and distorted by the matter it passes on the way here. Bending light like that is a prediction of general relativity. Measuring it across most of cosmic history is a test of whether relativity still holds at the largest scales, or whether our theory of gravity is the thing that is wrong. The second job is planets. Most known exoplanets were found by watching a star dim as a planet crossed it, or wobble as a planet tugged it. Both methods work best on planets close to their star. Roman uses a third method, gravitational microlensing. When one star passes exactly in front of another, its gravity focuses the background star's light and it briefly brightens. If the foreground star has a planet, the planet adds a second, smaller spike to that brightening. It works at enormous distances, and it works for planets far from their stars, the cold outer regions that the other methods miss almost entirely. It can also find planets bound to no star at all, drifting alone between them. Rogue planets. There may be a great many of them, and microlensing is more or less the only way to count them. The telescope will sit about 1.5 million kilometers from Earth, at the point where it can keep the Sun, the Earth, and the Moon all behind it at once and stay cold. It cost about $3.2 billion, and it is going up 8 months early, which is not a sentence often written about large space telescopes. It is designed for 5 years of operations, in a place where nobody can go and fix it. This week, the observatory was sealed inside the fairing at Kennedy Space Center. On the 30th of August, it flies. Roman never saw it. She died before it had her name on it. The naming came 17 months after her death. There is a temptation to make this story tidy. The girl who was doubted, the telescope with her name on it, everything settled. It is not quite that. She spent her career being the only woman in the room, was denied tenure because of it, and left research because the door was shut. What she did instead was build the room that everyone else now works in. She once said that she had not expected to have a career at all, and that she had been very lucky in her timing. Read her record, and the luck is doing less work than she suggests. Every space telescope that has flown since sits on the program. She started with a clean slate and a budget in 1959. And on Sunday, a mirror built to watch the ground will open its eyes on a billion galaxies under the name of a girl who ran an astronomy club at 11 and was asked what kind of lady takes mathematics. Thanks for watching.